Pre-algebra students, we are in lesson 14 today, and I've got some circles on the screen because I want to talk about fractions today, and then we're going to talk about expanding and reducing fractions. You guys should all be familiar with what a fraction is. A fraction is a part of a whole. Write that for us up here. A fraction means a part of a whole. All right, so for instance, I have one whole circle here, and I have divided it into 4 parts, and it's 4 equal parts. That's important to understand about a fraction, is that when we divide something into parts, it's always going to be talking about equal parts, all right? So in this circle that has been divided into 4 equal parts, only one of the parts is shaded. So we can write a fraction that represents the parts that are shaded. One of the 4 is shaded. Just like in this circle, 2 out of the 4 are shaded. And in this circle, 3 out of the 4 are shaded. And in this circle, 4 out of the 4 are shaded. And we know that when we have the same amount as in the denominator, this is the top part is the numerator, the bottom is the denominator. When these two numbers match, we know we have one whole piece because we have all of the parts we need to make one. So when you have the same number on the top and the same number on the bottom, that is equal to 1. And it likewise, what we can say is, because a fraction is a division problem, 4 divided by 4 is equal to 1, which we know is also true. So the mathematic relationship or correlation between a fraction and a whole number stands true when we think of it in those terms. Now, we know that we can reduce fractions and that fractions can have different denominators but then have the same value, and I've illustrated that for us here. In this picture, I have divided the circle into 2 equal parts, and 1 out of the 2 parts is shaded. In this circle, it's the same as the one we have above. We have 4 equal parts, and 2 of the 4 parts is shaded. But if we look at the picture, we can see visually that we can do a visual comparison and know that they're the exact same amount of the circle has been shaded. And so these 2 fractions down here are equal to one another. They have the same value. And we know by looking at that, we can draw the conclusion that the denominator and the numerator have a relationship to one another that can be reduced or increased relative to the number of parts you have in the denominator. All that means is if you can divide the top and the bottom, the numerator and the denominator, by the same number, then you can do that and it will have the same value. If I divide 2/4 by 2 on the top and 2 on the bottom, I get 1/2, which is the same value as the original circle that I have illustrated here. So this just gives us a visual representation of what fractions look like and how to kind of put them in our head when we're thinking about them, because we're not going to always have an illustration. We're going to most likely just have the fraction themselves whenever we do calculations. So being able to relate it to a picture is a good tool to have in your toolbox. It will help you to relate the fractions to one another later on, especially when we have to reduce. And that's what we're going to work on now. We're going to work on, first of all, expanding a fraction. So going from 1/2 to 2/4. And then we're going to do some practice problems where we reduce the fraction, where we would go from 2/4 to 1/2. So when we expand a fraction, we multiply its value or its representation by a number on the top and the bottom. And as long as we multiply by the same number on the top and the same number on the bottom, we do not change the value of the fraction. So for instance, if I took the 1/2 and I multiplied by 2 over 2, the same on the top and the bottom, this is ultimately, if you think about this, 2 over 2 is 1. We know that the same number over the same number is equal to 1 because 4 divided by 4 is 1, 2 divided by 2 is 1. So it stands to reason that as long as we are multiplying by the same number on the top and the bottom, we're actually just multiplying by 1. And anytime you multiply a number by 1, the value stays the same. And so that is the mathematical truth that backs up the fact that we can multiply a fraction by the same number on the top and the bottom and keep the same value, because ultimately we are multiplying by 1. So when I do this, I get 2 over 4. Now we know from the illustration that 2 over 4 is exactly the same as 1 over 2. We just multiplied it by a version of the number 1 to get a different denominator. We're just breaking it, basically we're breaking it into more parts, but it's staying the same value. All right, now I wanted to illustrate that to you. So you can see, because 1/2 times 1 is still 1/2, right? And this is ultimately the value of 1. All right, so let's do some practice problems. Let me clear the page. If it will let me. There it goes. Oops. Clear the page. All right, so let's start with example 14.1. We are going to expand the fraction. Expand means to multiply. So we're going to expand 3/4 so we get a denominator. And Miss Tracy can't spell denominator, of 24. So what we need to do in order to get there is to figure out what the factors of 24 are with 4. So how do we get to 24 when 4 is one of our factors? Because we're going to have to say 3 over 4 times the same number here in order to get a denominator of 24. So I know that 6 times 4 is 24, so I'm going to multiply by the top and the bottom by 6. So 3 times 6 is 18, and 4 times 6 is 24. So this is the same value as 3/4 because we ultimately multiplied by 1. We just broke it into more parts. Okay, that's pretty straightforward and easy. You guys are going to be able to do these in your sleep. We are going to write each number. So let me put that up here. Write each number with a denominator of 20. All right, and these are the numbers they want us to write with a denominator of 20. So we have to write 5 with a denominator of 20, and we need to write 3/5 with a denominator of 20. All right, so how do we turn a whole number into a fraction? We put it over 1. Because 5 over 1, 5 divided by 1 is 5. So that is a fraction turning a whole number into, or that is turning how you turn a whole number into a fraction. You put it over 1. That's all you have to do. So to give it a denominator of 20, we know that 1 times 20 is 20. Those are the factors we need to use. So we're just going to put 20 over 20. And we know that's the value of 1, so it does not change the value of our fraction. 5 times 20 is 100, and 1 times 20 is 20. So this is a fraction that has a denominator of 20, but still has the same value as 5. All right, for 3/5, we need to find the other factor that goes with 5 that makes a denominator of 20. So 3 over 5 times some number over the same number is equal to, not 200, Tracy, 20. Okay, so 3 over 5. 5 times 4 is 20. So 4 over 4 is what we need to put here. Still the value of 1. 3 times 4 is 12. And 5 times 4 is 20. So 12 over 20 is the same value as 3/5. Okay? All right, so let's look at a couple of practice problems that reduce fractions. So 14.3, we're going to reduce 30 over 45 to lowest terms. Sometimes reducing, well, not sometimes, reducing is harder than expanding, because when you're expanding, you're told where you need to go. So finding the other factor is not hard. Reducing, when it just says to lowest terms, you have to do a little bit of playing around with the numbers in order to figure out what the lowest terms are. So first, let's start with what we know about 30 and 45. We know that a number is divisible by 5 if it has a 0 or a 5. So we know that both of these are divisible by 5. So we can do that. We can divide by 5 over 5. And again, that's ultimately the value of 1. So the value here stays the same. 30 divided by 5 is 6. And 45 divided by 5 is 9. But I see another relationship here, and that is 6 over 9. We know those are both multiples of 3. So I can divide by 3 over 3, which is again the value of 1, which means this value stays the same, because any number divided by 1 retains its value. 6 divided by 3 is going to be 2, and 9 divided by 3 is going to be 3. So reducing 30 over 45 to its lowest terms would be 2/3. Now there is another way that you can do this, and that is by finding the factors of both the numerator and the denominator. So let me show you an easy way to do that. We can just think about, all right, I'm going to draw my line. What are the factors of 30? Well, I know 3 times 10, and I know that 10 is 2 times 5. Right, that's as far as I can go with that. With 45, I know that it's 5 times 9, and 9 is 3 times 3. Now to reduce, all I have to do is eliminate the same factor on the top as I do on the bottom. So cross out the 5s, cross out a pair of 3s. All I have left is 2 over 3. That is the same answer I got up here. And it's a little bit fewer steps. It's a little bit cleaner way to do it. So if you would prefer to do it like this, or start trying to do it like this to kind of wrap your head around how that works, I highly encourage that. So let's do one more. 14.4. And we are going to reduce, let's see, is it 36? No. I can barely see because I'm old and I have to wear eyeglasses. 16 over 32 using the GCF. All right, of both of those. The GCF of 16 and 32. So what I did in the previous method was use the GCF of 16 and 32. And the way we find the GCF is to find the factors of each number. So we know 16 is divisible by 2, be 2 times 8. 8 is 2 times 4, and 4 is 2 times 2. So that is all of the prime factorization of 16. Let's do the same thing for 32. So we have 2 times 16, 2 times 8, 2 times 4, 2 times 2. So what we need to do is eliminate the common factors. So here's a pair of 2's, 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 and that's it. Now, if we eliminate all of the factors in either the denominator or the numerator, you always have a remaining factor of 1, because anything times 1 remains the same, right? We know that. It's called the identity property of 1. Any number times 1 is the value of that number. So whenever you eliminate all the factors, you can put a 1 in its place, and it's like a placeholder. It holds the value. So that means we have factors of 1 over 2 remaining, and that is the reduction of 16 over 32 using the GCF method. And the GCF method is just a little bit faster than dividing and dividing and dividing. All right, that is that's all we have for lesson 14. So not so hard today. If you have any questions about anything we've done up to date, please message me. Don't put it off. Make sure that you are contacting your instructor whenever you have a problem in any of your subjects, because this is all about you getting what you need to go forward in life. So do not hesitate. That is what we are here for. We are here to help you. So contact me if you are stuck on a concept. I want to help you understand it and get over it, get through it, and master it. And that's all I have for lesson 14. I will see you in lesson 15.